Hello. After some time, I'm back. Sorry, I was not available last week, so there was two recorded session that was there. I hope you have watched it. Sorry for there was some mismatch happened. Part 3 was released before part 4, so that is one mistake from our side, and that will be corrected from our side. Sorry, that will be corrected in the playlist. You can go and check the playlist, it will be corrected over there. So the correct order of chapters along with the topics is corrected in the playlist. Okay, the playlist link I will post it in the comment section, so do check that out. How to access the playlist. We have already completed 2 chapters, electric charges and fields, as well as electrostatic potential and capacitance. So today we are going to start with the I think the thumbnail is wrong. So today we will start with current electricity. Okay, so current electricity, let us look into the topics of current electricity. We will be basically discussing the chapter into mainly 2 parts. Okay, this, even though this is a super important chapter, but in terms of content length the chapter is not huge, so we have decided that okay, let's discuss the chapter into 2 parts. First part, that is today we are going to discuss electric current. Okay, let me change the pen. So electric current and Ohm's law, limitations of Ohm's law, combination of resistances, resistance and resistivity, drift velocity, conductivity and mobility, and electrical energy. So these are all be discussed in our part 1. Just a second. This will all be discussed in our part 1. And remaining parts, cells, combination of cells, okay, Kirchhoff's laws, Wheatstone bridge, these will be discussed in our part 2. So this will be discussed in our part 2. And part 2 is when? It is as early as the coming Thursday there will be physics lecture. So every Tuesday and Thursday there will be physics classes. When I will be coming live, I will be taking lectures. So whatever doubts, whatever questions you have, obviously you can come and ask me in the live class itself, right? So if you have any doubts, suppose you are watching rewatching some of the previous videos which I have done in our channel, and you have some doubt, you can come and ask me anytime. As long as I'm live, you can ask me the question. Okay, now let's start with the concept of electric current, which is very important. Okay, the net amount of charge Q flowing across the area in the forward direction in the time interval t, then current is defined as charge divided by time. That is the basic definition of electric charge. In the chapter magnetism, we will see there is another definition of current, especially the unit of current. Okay, now let us understand the meaning of that. Now so far, first 2 chapters we have discussed about hi Akshara, what are you saying? I cannot read your comments, sorry. It is getting yeah, Akshara, we will share the results as well, don't worry. So first of all, let us understand the first 2 chapters we have discussed about static charges. Charges were static, whatever electric field, electrostatic potential, in all cases it was basically based on static charges. Now we are slowly moving into moving charges. The first step towards that is current electricity, and more we will study in the next chapter, moving charges and magnetism. Okay, so so far charges were static, so some electric field, some Coulomb force, etc. were there. Now we know that a conductor, which is basically a metal, has a lot of free electrons. Okay, so those electrons or the charges, when they move across a conductor, across a cross section in the forward direction, then if the charge, that is total charge that is moved, is Q, the time taken to move that charge is T, then current is given by Q upon T. Now, even though current is defined as Q by T, current is considered to be a fundamental quantity. Okay, fundamental quantity means its unit, it is independent of anything else. Even though we are defining current as charge per unit time, generally if it is defined like this, the quantity is generally considered to be a dependent quantity. So the question was whether to take charge as an independent quantity or current as an independent quantity. So it was realized that if we take current as an independent quantity, a lot of our equations or the dimensional formulas becomes easier. That's why current was taken as independent quantity. So current is considered as an independent quantity and its unit is ampere and its dimension is A. Okay, dimension of current is given by third bracket A. Okay, that is the convention. Right, so this is very important point to remember, that current is a fundamental quantity, its unit is ampere, denoted by capital A. Okay, some people write like this. Remember, this is wrong because ampere, sorry, I made a mistake. If you are writing ampere like this, it denotes the name of the person who worked on the current electricity. Okay, this is a name of a person, and based on his name, the ampere unit was dedicated. So either you write like this or you write capital A. Okay, ampere or capital A is the unit of current, not capital A M P E R E. Okay, so just be careful, do not write capital A. Now, currents are not always steady. So this up to this point we are somewhat familiar in our lower grades, right? Okay, Akshara. Just so far whatever we have done, current is equal to Q by T, etc., charge by time. So those things we have studied in our lower class, especially class 10th. We have actually have an idea about current is equal to Q by T. Now, because we are now in class 12th or second PUC, that definition seems little old, little childish. So we have to improve the definition as well. So current is whatever we say, the charge that is flowing through a conductor, amount of charge is not always constant. Okay, it varies with time. Okay, so amount of charge that is flowing through a conductor is not always constant. So for example, suppose in 1 second I measured, say 10 electrons passes through the conductor. Another 1 second I counted 15 electron passes through the conductor. Another 1 second I counted only 8 electron passes through the conductor. So the amount of electron which is passing through the conductor is not a constant, it is varying with time. So far whatever we have discussed is called steady current. Okay, even though in this chapter particularly we will mostly discuss about steady current, in the chapter alternating current, there we will see how the fluctuation of current happens, but still we need to know the definition, because we are talking about current, so we need to know the definition, real definition, when the current is actually not constant, which is slightly fluctuating every second. In that case, we define the current is as limit delta t tends to 0 delta q by delta t. So what is delta q? Delta q is the delta q amount of charge is passing through the conductor in a very small amount of time, delta t, and ideally if you take delta t tends to 0, the entire thing becomes a differentiation, right? This is the definition of differentiation. So I is equal to dq by dt. That is the actual definition of current, but so far we have simplified this equation as I is equal to q by t, but in reality it is dq by dt. So if they give you, say, charge is given by a relation, say at square plus bt plus c, then what is the current at t is equal to, say, 5 second. So you have to do, what you have to do, you have to say current at t is equal to 5 second, we have to differentiate it with respect to time and then put t is equal to 5. Then whatever value you will get that. That's it, right? So this is a very simple type of concept, and so far I know many of you encountered differentiations in your PUC 1 and started thinking physics is difficult. Now once your differentiation is now done, now you are very much familiar with differentiation. Now these things actually looks much easier than how it was the situation in PUC 1, right? Now let's move on. Electric currents in conductors. Now we are moving on to conductors. So electric charges experiences a force in the presence of external electric field. Okay, the electrons being negatively charged move opposite to the direction of the electric field. So we know that electric field, whenever we apply electric field, and if you keep a charge over here, the charge will experience a force. What is that force? If you remember, force was given by Q into E. The force acting on a charged particle is given by Q into E. Now obviously based on the sign of the charge, it can be in the direction of electric field or it can be in the direction opposite to that of the electric field. So because in conductors only electrons carry current, okay, so we consider that current is being carried away in the opposite direction. Okay, so if you apply electric field in this direction, the charged particles will be carried in the opposite direction. That means the force acting on the charge will be in opposite direction of the electric field. Okay, so the force acting on the charged particle is on the opposite direction of the electric field. This is very, very important part to understand. And so far in the electrostatic chapter, even if there is a force acting on the charge, we assumed that the charged particle is still static. Now what we are doing, we are allowing the charged particle to move in the electric field. Now we will see what will happen. Okay, so metals having a large number of free electrons, these electrons accelerate in the presence of external electric field. Why they accelerate? Because our great grandfather told us force equals to ma, father equals to ma, so F is equal to ma. So from there we can say that the force acting on a charged particle is Q into E. So that should give me the acceleration A is equal to QE upon m. Right, so we will get the force acting on the charged particle. If there is a force, there will be an acceleration. Okay, if there is a force, net force, if the net force is not zero, there will always be an acceleration and the electron will start accelerate in the direction opposite to that of the electric field. Okay, this gives rise to the electric current. This is the basic simple explanation of the electric current. We will see a slightly further ahead in our discussion today. We will see the exact nature of the current. So don't worry. Okay, so the acceleration basically gives rise to the, this is the reason, this is the cause. If you apply electric field, in the presence of electric field, the charges move and that is the source of electric current. Okay, now whenever we say electric field, another quantity which is associated with electric field is electric potential. If you remember, electric field can be written as minus dV by dx. So if there is a distance involved, if there is a potential gradient involved, then there will be an electric field. So electric field can be applied by having some static charges or by applying a potential difference. Okay, in this chapter, instead of saying dV, that entire dV thing will be replaced by V. Okay, simply V. Okay, the potential difference itself is denoted by the symbol V. So actually in terms of electrostatics, potential difference was denoted by dV. But in this chapter, the dV will appear so many times. Instead of having dV, we say, okay, let me denote V for electric current. Whenever electric current is coming, V represents potential difference, not actual potential. Okay, in electrostatics chapter, V represents actual potential, whereas dV represents potential difference. So there is a small change in our mindset, in our expressing the quantities. So just be aware, here V represents the potential difference, not actual potential. Okay, now Ohm's law basically governs how charges flow in a conductor. Okay, this is the governing council. For example, in every country there is a rule, there is a law right? You cannot break certain laws, okay, or you will be jailed. Similarly, in case of electricity, they also have to obey a law, that is Ohm's law. Okay, if temperature and other physical conditions remain same, the current through a conductor is directly proportional to the applied potential difference. Okay, so what are all the meaning of this? Physical conditions, temperature. So first of all, if you change the temperature, this law is no longer valid. Secondly, other physical conditions. What is the meaning of other physical condition? For example, you are applying say something to a metal is being carrying some current, and metal gets heated up and it melts. Then also what is your question, Akshara? KCET rank under 100 possible if I daily join this. Akshara, not only joining this, but also you have to practice questions, a lot of practice along with the attending the lectures. Yes, it is possible. Okay, below 100 I will not say. Below 100 you need to stress yourself as well. You have to follow the plan. We are sharing the plan as much as possible in our channel. If you stick to one plan, attend the lecture, okay, follow your NCERT textbooks as well as solve numerical, not numerical, I will not say numerical, also practice MCQ questions, fresh as well as PYQs, then you will be very much ahead in top 1000 rank. Okay, top 1000 rank is achievable. It is not super difficult. First thing is obviously PU lectures will be also be there. We have started our PU2 FA1 series as well. So PU2 lectures will be there for your PU exams. This is most focused towards KCET preparation as well as PU preparation as well, but this lectures are mostly focused on KCET, and for PU exams we will be doing more one shot, then we will be also doing more question answers of PUC exam. So if you follow everything, definitely you will be well up ahead in top 1000. We have produced ranks in top 1000 and we will produce rank in top 1000 from YouTube only, don't worry. Okay, now so this is the potential difference. When you apply potential difference across a conductor, the conductor gets heated up, and because of the heating the wire melts. If the wire melts, then the physical conditions are no longer same, so it will again not obey Ohm's law. So temperature and other physical condition means the physical state basically. Okay, some cases it can be transferred into a plasma. So in that case also Ohm's law will no longer be valid. So these are the two conditions that has to be obeyed for Ohm's law to follow. Okay, now a current through a conductor is directly proportional to the applied potential difference. Okay, mathematically it can be written as V is proportional to I or V is equal to IR. Now actual Ohm's law is I is proportional to V. Actual Ohm's law is I is proportional to V. Current is proportional to applied voltage. That's what the law states. Okay, then why we write V proportional to I? Because there is a mathematics that says if X is proportional to Y, Y can also be written as proportional to X. So using that loophole, we are writing this. Okay, because we generally write proportionality constant in multiplication. So V is equal to IR, that is the standard form. Okay. This is the standard form of Ohm's law. The constant of proportionality R is called, just a second. The constant of proportionality R is called the resistance of the conductor. The SI units of the resistance is Ohm and is denoted by the symbol omega. This is called omega. The name of the symbol is omega. The resistance R is not only depends on the material of the conductor but also on the dimensions of the conductor. Okay, so this resistance R does not depend on current or voltage. It depends on the material and dimension, how big, how large. We will come to that in a while. But before coming into that, just wanted to showcase our results of NEET exam that happened. The results was published very recently, and these are our toppers, starting from AIR 10 from one of our Vedantu campuses. Then we have Vishrut Sarthak is from Vedantu campus, Vishrut is from our Diksha Vedantu campus. So Hemant is there, Murugeshwaran is there, then we have Sri Charan, Ayush, Avinash, all of them have achieved an excellent rank, and if you see, over 800 Vedantu students cleared NEET 2026. So they are eligible to become a doctor, which is a fabulous achievement on our own, right? And if you want to achieve success in KCET exam, then you can join our Pariksha Veera batch, which is currently live. Obviously classes already started, but you can still join the batch. The link to join the batch is given in the description. I will discuss more about the batch at the end of our session. Let's continue. So as I mentioned, resistance of the conductor depends on the dimensions as well as the material. So we will see how it depends on different things. So first, resistance on length. Okay, so if suppose you are moving on a highway, okay, you are moving on a highway and the highway is very long. The highway is very long, so it will take a longer time for you to reach from one end to another, right? There will be traffic on the highway, okay, there will be a lot of cars in between, and if you are from Bangalore, then you know how worse it can be, right? Bangalore outer ring road, if you are driving in the outer ring road, you do not know how long it will take if you are traveling from one point to another, right? Because you have to navigate through the traffic and then you have to move from one place to another. So that is basically says that if the length is long, the electron will take longer time, the electron will be slow as well, so resistance will be higher. What is the meaning of resistance? Resistance means the electrons are trying to move through the conductor. Electrons are trying to move through the conductor, okay? Suppose this is the electric field you applied. Electrons are trying to move in the opposite direction because of the electrostatic force acting on them. So electrons are moving in the opposite direction, but the metal itself is not allowing that to happen, because metals also have a lot of positive charges present inside the nucleus, and there are other electrons as well. They are saying don't go. For example, you are trying to study and your friends are saying that, hey, don't study, you have to study this before exam, you study, you will pass, you will get a good college. Okay, so basically they are trying to stop you from getting a good preparation. Similarly, the other electrons are also saying, hey, don't go, why are you moving? Okay, either they are saying take me with you, or they are saying don't go, play with me. So like that is happening, and that's why the metal is applying a resistance, right? So resistance is being applied by the conductor itself, and that is an inherent property. Now longer the path it has to travel, longer those interactions, longer those collisions will happen with other electrons and other atoms, okay, and that's why the electron will slow down. That's why longer the path, slower the electron will be, and more will be the resistance. So resistance is directly proportional to the length of the conductor. Secondly, the resistance is inversely proportional to the area. What does that mean? Let me give you one real example. In the same highway you are traveling, okay, the highway is, instead of narrow highway, it is a broad highway. Highway is much broader, okay, even though there are a lot of traffics present, okay, you can still pass between these two traffic, between the traffic easily, because there is a lot of space available to you. So you are traveling in a 6-lane highway, suppose, okay, nice road, for example, or Mysore Bangalore highway, okay, they are very large broad highways, okay, even there are traffic, you can easily navigate through them, and you can pass quickly. So that means broader the path is, okay, easier for the cars to move. Similarly, in case of conductors, if the cross-sectional area is more, electrons can easily navigate through the other electrons and reach the destination faster. Okay, that's why if the cross-sectional area is more, then the resistance will be less. If the length is more, okay, if the length is more, then the resistance will be higher. If cross-sectional area is more, resistance will be smaller. Okay. Now, if you combine two proportionality equation, we know that suppose A is proportional to B, and if A is also proportional to C, we can write A is proportional to C into B. And if you want to remove the proportionality sign, you have to add a constant into CB, where we say K is a constant of proportionality, right? Similarly, here also R is proportional to L, R is proportional to 1 upon A. So if you combine them, it will be R is proportional to L by A, or R equals to rho L by A. Here rho is the constant of proportionality, and this is called resistivity of the conductor. It is a property. This is a property of the material of the conductor. Okay, so this rho actually is the property of the conductor itself. So based on aluminium or silver or platinum or normal iron, so or copper, whatever you are using, based on that the rho value will change. So even if everything is same length, same cross-sectional area, but the material of the wire is different, then still resistance can vary, because very important part is there, because the material is different. So this rho is actually the inherent property of the material that changes the resistance. Okay, so resistance is basically the property of length, area and the material. Okay, so resistance depends on dimension. These are the dimensions. Dimension means length, area, they are called dimensions. Okay, length, diameter also, but diameter can be added into area. Okay, area is equals to pi r square. So from there you can link it to the diameter or radius. So length and radius in general, but here area is also an extended part of the radius. So dimension of the material, that is size, and material itself, that is rho. So rho is the property of the material, whereas L and A are length and area. Okay, it can be still be remain same, but resistance can still vary. So that means you have studied same hours as the topper. Okay, but topper scores more than you. Okay, because they have maybe slightly better understanding of the things. So you are not understanding as much as the topper. Toppers understood better that okay, I have to start now, I have to prepare more, and I have to focus. So that's why they are scoring well. Whether you are also studying, but when you are opening your book becomes your YouTube live. Okay, your books, or you are watching YouTube live, but your mind is actually scrolling Instagram reels. So then what can we do? Right, so you have to stay focused in the same thing, then your resistance will be equal same as the topper, right? Let's see one question. A wire of resistance 3 ohm is stretched twice to its original length. The resistance of the new wire will be. So this is a very common themed question of KCET. So here the resistance was 3 ohm initially, okay, and nothing mentioned. So initially suppose this is the wire of 3 ohm. Now if you stretch it, you will observe that the wire, you are not adding any extra material to the wire. Okay, so what will happen if you stretch a rubber band? What happens to the rubber band? The rubber band, it gets extended, but its width becomes smaller. Okay, it becomes thinner. Right, so if you stretch the material so that its length becomes double, its area of cross section will be halved. Okay, you have to remember, if length becomes double, if length, suppose this is length and area, now new length is 2L, area will be A by 2. Okay, so when you stretches a wire, then its length becomes 2L, area will be A by 2. Now in the exam you do not have the time to solve in a longer method, you need to know a shortcut. So I am going to teach you a very cool shortcut to solve such questions. What is that? Remember that the new resistance will always be N square old resistance. Now what is N? So this N is actually the factor by which the length is changed. Okay, by the, for example, in this question, the factor is 2. The wire is stretched to double. Okay, if it is stretched to double, the factor will be 2. If it is compressed to half, so it can be normal multiplier, it can be fraction as well. Okay, so for example, the length is compressed to half. So in that case, you are compressing the wire to make its length half. So in that case, the n factor will be half. Okay, so if you have to read the question very carefully. Sometimes it says that the length is increased by 10%. So in that case, can we use this formula? Yes, in that case also we can use this formula. So if the length is changed by 10%, the new length will be 1.1 times more than the previous length. Okay, 10 times more, 10% more means 1.1 times. So in that case, n will be 1.1. 20% means 1.2. 200% means it will be 3. 200% means, always remember how to calculate that. In case of percentage based question, it can be little tricky. Remember very simple thing, 1 plus the percentage divided by 100. That will be your n. Okay, n will always be 1 plus the percentage value divided by 100. That will give you the n value. Okay, so in every case you can use this simplified method and you can calculate. So many students will think that 3 the length double means it will be 6. It is actually wrong. Okay, so you have to calculate, instead of here length is doubled, so 2 square into 3, that will be 4 into 3, that is 12 ohm. Okay, so correct answer is 12 ohm, option D. Yes, Amog, you are absolutely correct. Okay, but make sure that you understand that the longer format actually requires you have to use the formula R is equal to rho L upon A. Okay, this is original. The new one will be rho L dash upon A dash. Okay, then put the value of L dash to be 2L, A dash to be A by 2, and you will see that it will actually 4 times the original value. But if you remember this formula in the exam, because you are writing very fast, you do not have that much time, so you have to solve it quickly, and that way you have to remember this formula. Very easy, simple formula. If length is doubled, n square, 2 square into old resistance. If length is halved, it will be half square into old resistance. Okay, the same question, if it is asked that length is halved, then it will be half square into old resistance, like that. Very simple. Okay, don't need to worry too much about it. Now next is drift velocity and mobility. So these are the two very important concept in current electricity. So that's what we are going to explain. Okay, what is drift velocity? First, so far we have seen that we have a conductor, and in that conductor there are a lot of electrons present. Okay, and random. It is not some organized way, they are randomly present. Now normally they are still moving inside the metal, but their average motion is count to be 0. Random motion, sum or average of random motion is always 0. Okay, now because of the random motion, the average coming out to be 0. Now what you have done, so basically in a classroom, all the students are present, teacher was not there, so all of you are talking, they are all throwing something towards each other, like that. So it is a chaotic classroom. So average learning 0. So electrons are moving, but their average motion is still 0. Now what you have done, you have applied an electric field. Okay, some electric field you have applied by applying some potential difference. Okay, you have some battery. Through the battery you have added some positive over here, some negative over here. Okay, some negative over here, and you applied an electric field. Okay, basically the potential difference that we say V is basically providing the required electric field. Okay, so you applied potential difference, and based on that electric field is applied, and based on this electric field, now what the electrons will do, they will start moving. Okay, and which direction they will move? They will move in the opposite direction of the electron. Of course, right? Electrons are negative, so they will move in the opposite direction of the applied electric field, and that motion supposed to be an accelerated motion. That motion is supposed to be an accelerated motion because our great grandfather Newton told us father equals to ma, there is no difference between father and mother, so F is equal to ma, so there should be some acceleration. But when you go deep inside the metal and observe the electrons properly, you will see that electrons are actually not accelerating, but they are moving with the constant velocity. Okay, so what is that constant velocity? That we are going to discuss. So even though you applied an electric field, the overall electrons present in the metal, okay, they are still in a random motion. Their random motion is still there. Okay, the random motion, whatever was happening, that is still there. But including that random motion, the electrons are still slowly, that center of the motion is slowly moving, shifting towards the opposite direction. The electrons are still vibrating. Electrons cannot stay quiet. Okay, they are always vibrating, especially the free electrons. They are always in motion. But when you apply an electric field, they do not immediately fall into lines and all of them don't start to move in the same direction. That does not happen. Okay, if you have that idea, that picture, it is basically a microscopic picture that you have to imagine in your head. Okay, when electric field is applied, what happens to the electrons? Do they immediately start moving in the opposite direction? No. Their randomness or the chaotic motion is still there, but even with that chaotic motion, electrons slowly starts moving in the direction of the opposite direction of the electric field. And because there are other electrons present, there are other collisions happening, the average motion is not accelerated, but it is a constant motion. And for constant motion, what is the term that we use? We use velocity. Okay, so velocity is more accurate than accelerated motion, because acceleration is not happening. Electrons are not accelerated, even though there is a force, even though there is a acceleration supposed to be there, but electrons are actually drifting with the constant velocity. Drifting means what? Drifting means if you drop something in water, suppose you went into some pond or something, you dropped some object, some floating object in the water. As the water is moving, surface is moving, the object is slowly moving along with the surface. That motion is called drift motion. Drift motion is, it is not like a speedboat. Okay, it is just floating on the water and it is slowly moving along the wind or like that. Okay, so that is called drifting. Okay, so same thing happens to the electrons as well. They are actually in the presence of electric field, even though their chaotic motion is still present, they are slowly start to move in the opposite direction of the electric field, and that velocity is called drift velocity. So drift velocity comes because of the electric field, of course, and also the property of the material which is trying to stop the motion. So combination of both of them gives rise to drift velocity. We will see the expression of drift velocity and how it depends on different things. But so drift velocity is basically a constant motion of the electron, even though remember this is an average velocity because electrons are still in the random motion. The random part of the electron motion of the electron is still present, but now the average direction has changed. Initially the average was 0. Now average motion is in a particular direction with a fixed value, and that is called drifting, and that motion is called drift velocity. That motion is called drift velocity. Okay, now what is mobility? Mobility means how fast the electrons can move from one place to another. Okay, mobility determines, even though they are also chaotic, okay, the electrons are still chaotic, but if the mobility is very high, then even though with the chaotic motion also, the electrons can move from one end to other very fast. Okay, so how much distance it travels in 1 second is basically the measure of mobility. Mobility is basically electric field per drift velocity. Okay, we'll see that as well. So mobility is how fast the object is moving per applied electric field. Okay, so that is mobility definition of mobility. We will see relaxation time as well. What is relaxation time? So electrons present in the metal, they are always colliding with other electrons. So electrons colliding with other electrons, changing its direction. Okay, it is always in collision motion. So in between two collision, the electrons are moving in a straight path, same as the kinetic theory of gases. Yes, Akshara, all the shortcuts, whatever is shortcuts are there, we will definitely teach you. Don't worry about it. Okay. So whenever the electrons are colliding with each other, in between the collision, they are moving in a straight line path. Okay. So when they are colliding with another electron, it can change direction. But it is unlike say Messi is running with the ball, when he is there is a defender in between two defenders, he is running in a straight line. That does not happen in football, but imagine in your head. Okay, Messi is running with the ball, but here is the defender, he crossed it, and then he running straight towards the next defender, and when he encountered the next defender, he changed his direction. Okay, so like that electrons are doing. Electrons, when they are colliding between two electrons, they can change their direction, but they normally they cannot do go like this. Okay, they have to go in a straight path when there is no other collision. In between two collisions, there is a collision number 1, there is a collision number 2. Between the collision, the electron will travel in a straight line path. Okay, now the average time taken by the electron to move this path, this is called relaxation time. So you are this is period 1, this is period 2. Okay, you went to the college, first period is over, second period is about to start. So in between two periods, whatever time is there, that is your relaxation time, right? Maybe there is a small break, there is a lunch break, like that. So in between that time is called relaxation time. We do not want to study at that point of time, right? So same is here as well. So the intermediate time between two collision is called relaxation time. The average time duration between two collision is called relaxation time. In between that time, electrons are relaxing, they are moving in a straight path without obeying anyone else. Okay, and you can calculate the mean path as well. This is called mean free path. Mean free path is obviously not part of our discussion today. So two things very important: drift velocity. Drift velocity is the average motion of the electrons in the direction opposite to the applied electric field. If electric field is 0, drift velocity is also 0. Okay. Secondly, based on how fast an electron is moving per applied electric field, that gives rise to the mobility of the electron. That means that determines how quick electrons can move from one end to other end. Okay. Now let's see the formulas of all of them. So drift velocity is given by minus E by m into tau. Okay, we will derive this equation in our PU section of the class, not in this on this lecture. Okay, so Vd is equal to minus E by m into tau. So what is E? Charge of an electron. E is applied electric field. M is mass of electron. Tau is relaxation time. Now very important to note that there is a negative sign. Why there is a negative sign? Because if you apply electric field on this direction, the electrons start moving in the opposite direction. So drift velocity and electric field, they are in mutual opposite direction, and that's why there is a negative sign. The negative sign shows that the drift velocity and electric field, they are in the opposite direction. Now this formula is important for PU, but not so much for KCET. For KCET, this is the formula that you must remember. I is equal to NEAVD. Okay, what is N? N is number density of electron. That means you take 1 unit volume of the material. Okay, whatever material that you are using, the volume must be 1 unit. 1 unit means 1 meter square. Okay, usually if in SI system it will be 1 meter square, and whatever number of electrons are present inside that volume, okay, total number of electrons that can move, that is called number density. Okay, the free electrons present inside this 1 unit volume, that is called number density of electrons. So suppose you have a very small thin wire, right? So thin wire do not have that many electrons, but you have to consider a bulk of 1 meter length, 1 meter height, 1 meter width. So total number of electrons present in that cube, that is called number density of free electrons. So total number of, not total electrons, total number of free electrons present is called number density of free electrons. Okay, E is charge of electron, A is cross sectional area of the conductor. Okay, so I is equal to NEA VD. Now one more interesting fact from here, suppose we have a conductor shaped like this. Okay, current, steady current I is passing through this. Okay, now suppose at this end the area is A, the drift velocity is VA. At this end the area is B, the drift velocity is VB. Okay, at this end area is A, the drift velocity is VA. At this end area is B, drift velocity is VB. Now is there any relationship between VA and VB? So that is one interesting fact. Because current is constant, number density is constant, charge of an electron is also constant. So that means if current, steady current means current is constant. So that means area into drift velocity is also constant. Area into drift velocity is also constant. So here A into VA must be equals to B into VB. Now based on who has greater area, the drift velocity will also be small or high. For example, VA is greater than VB in this particular example, because area A is smaller than area B. That means VA should be bigger than VB. You can calculate that VA by VB equals to B upon A. Now obviously B is greater than A, B is greater than A. That means this quantity must be greater than 1. Okay, bigger number by smaller number, value should be greater than 1, and from there you can say VA is greater than VB. This is a KCET question, came a few years back, and now this question is important in your PUC exam. PUC MCQ section, they might give you a sketch like that, and they will say which one has a bigger drift velocity. So you have to answer that. Okay. Now there is one more quantity which is called current density, and it is denoted by J. Now normally when we say current is a scalar quantity. Okay, current is a scalar quantity. Even though it has a direction, it does not obey the law of vector addition. That's why current is considered as a scalar quantity. Now because it has a direction, we have to have a certain quantity which is a vector quantity. What is that? That quantity is the current density J. Okay, current density J is a vector quantity, and the direction of current density is in the same direction, same as electric field. Okay, current density is same as electric field. Now one more important point that I forgot to mention, that when we say direction of current, direction of current is basically taken in the direction of electric field. Current is flowing in the same direction as electric field, even though originally the electrons and the drift velocity is happening in the opposite direction. Okay, electrons are moving in the opposite direction of applied electric field. When current was discovered first time, we did not know anything about this theory. Okay, without knowing the theory, we discovered it. It was an experimental success. While doing some experiment, okay, Voltas discovered some current, okay, and then it was transferred, and a lot of other things came into picture. But when the current was discovered, electrons was not even known. Okay, we only know that the materials have only single particle. They do not have any electrons or protons. So that point of time, current was discovered. Okay, it was assumed that some positive charge, some positive particles are carrying the charges from one side to another. Okay, so it was assumed positive charges are flowing. and that's why current direction actually taken in the direction of electric field. Okay, later on it was discovered, electron was discovered, proton was discovered, and it was realized that protons are not moving, electrons are moving, and then they said, okay, electrons are moving in the opposite direction. So when the final picture came out, okay, about current, then they realized actually electrons are moving in the opposite direction and not the positively charged protons, okay, not even ions. So that's why there is a contradiction over here, but remember, this came first, this came much later. So we for only for academic purposes we consider electrons. Otherwise when it comes the conventional direction of current, convention wise the direction of current is always in the same direction as electric field. Okay, now the mobility, the function of mobility mu is equal to Vd upon E. Okay, so as I mentioned, drift velocity per unit electric field. So how fast an electron is moving when you apply a certain electric field, that is the drift velocity, and its expression in terms of relaxation time. If you substitute this Vd over here and ignore the sign, you will get E tau by m. So this is the mobility in terms of relaxation time. Okay, what you have to do is just put this value over here and you will get it. Conductivity, conductivity is opposite of resistivity. Conductivity is opposite of resistivity. So if I say that this is a highly resistive conductor, that means its conductivity is low. Okay, so basically it's a opposite of resistivity, 1 upon rho, and it is defined by J by E. We will come to that, the derivation is there, and that is equals to N E square tau by m. Okay, so this is the relationship of conductivity. Okay, sometimes they will ask that starting from the expression from drift velocity, continue with the derive the expression for conductivity. So that is also possible. We will do that in our PU lecture. Okay, not in today's lecture. Next is Ohm's law in terms of current density. So Ohm's law is V is equal to IR. Now if you replace R by rho L by A, then I upon A is current density. So V is equal to J rho L. Okay, now electric field, so this is the L is the length of the conductor, V is the applied potential difference. Okay, so we know that by definition electric field is V upon L. Okay, ignoring the sign. So from there you can put V is equal to E into L. Okay, ignoring the sign, V is equal to E into L. Or now substitute that back over here, you get EL is equal to J rho L, L cancels, then E is equal to J into rho, or J is equal to E upon rho, 1 upon rho is sigma, so J is equal to sigma E. This is conductivity into electric field. So this is the alternative form of Ohm's law. This derivation is also sometimes important. Now in KCET, in this derivation, okay, not this final expression was asked, they asked based on this expression. Okay, that's why you are doing the derivation. Okay, they asked that A equals to B into C. Okay, A is electric field, B is current density, then what is C? Okay, most of you remember J is equal to sigma E and write C is equal to conductivity sigma. Actually not. Okay, this is not the expression. E equals to J into something, E is equal to J into rho. So this is resistivity. This is resistivity rho. So you have to identify them correctly, because each and every form of this equation is important. So E is equal to J rho or J is equal to sigma E. Okay, this comes first, this comes next. So based on this, KCET questions have came in the past, and now I think once PU question also came in the PU exam as well, one MCQ question for PU exam. So remember this, these are the small portions. Then when you study you forget, you just remember this, you ignore this, and in the exam hall you waste a lot of time to figure out what the value will be, or you just go through very fast, you just mention sigma is the answer. Actually no. Now is Ohm's law always valid? Obviously not. Ohm's law is not always valid. Sir, I have a doubt. I am not studying boards seriously. Will I study in last 2 months most of the time focusing on KCET? Yashwant, very soon chemistry classes will start. Don't worry. We are also finalizing the teacher. We do not have any chemistry teacher right now, but yes, it is almost finalized. We will get our chemistry teacher very soon. Don't worry about it. So as I am speaking, the team behind me is working on finalizing the teacher. So we will see the teacher very soon, right? And Akshara, I don't suggest you that you should only focus on your KCET. Parallelly, if you also complete the PUC preparation related to the same concept, for example, I did the theory part, you just go and check the derivation of the same. Your PUC preparation is done. Okay, PUC preparation is done. If you just go through the derivation once, J is equal to sigma E. Okay, sigma is equal to the expression for sigma starting from drift velocity. So those are the derivations that are important. Again, we will do some other calculations in the next class as well. For example, Wheatstone bridge, then cells in series, cells in parallel. So those are all the important derivations from this chapter. So whenever you are learning this, go and practice the corresponding derivations. Main 1 to 3 marker questions you can answer by watching this lecture alone, but for 5 marker and the numerical questions you have to do PU level preparation. Okay, for numerical questions we will do before your FA1 exam as well as in your midterm exam. So we will do there, but you also have to start practicing and you have to realize what are all your weak points. Okay, because if you practice some of the numericals, actually that will give you a clarity of understanding as well, how much you have understood. That is one important point. Along with this, you don't have to do a lot. Okay, you just invest half an hour to 40 minutes every day. That's it. Your PUC of the same chapter, same concept will be covered. So don't waste time on that. Okay, I will do that in the last 2 months. Then you are actually falling behind. Those who are already doing it, they will be much more ahead, because as I mentioned, a KCET preparation and PUC preparation should always go hand in hand. Now, limitations of Ohm's law. And Ohm's law is not always valid, even though I said that Ohm's law is like a law of current, but it is not always valid. So what are all the conditions that when the Ohm's law are not valid? First of all, V ceases to be proportional to I. Okay, V is no longer proportional to current I at very high temperature and at very low temperature. So even if the conductor is properly working, but at very high temperature and at very low temperature, the Ohm's law is not valid. V is not proportional to I anymore at these high or low temperatures. Okay, so this is number one. Number two, the relationship between V and I depends on the sign of V. So if the relationship between V and I depends on the sign of V, then we will say that Ohm's law is not valid. So for example, here we have taken one example. Okay, if you see that this one. So if you see that here the voltage is positive, current is going like this. Here the voltage is negative, the current is completely different. Current is going in completely different way. So both sides they are not obeying Ohm's law. So if current obeys based on the direction of current, okay, then we say Ohm's law is not valid. This is an example of PN junction. Okay, you will do the experiment on this. Also theory about this also is there. Now another condition is that the relationship between V and I is not unique. That is, there is more than one value of V for the same current I. So for example, if I just plot this graph, okay, you will see that, okay, it is mostly Ohm's law. Ohm's law normally gives you a graph like this, straight line graph. Okay, V versus I, because V is proportional to I. So normally V versus I graph is a straight line graph like this. But at very high temperature, the graph tends to go like this. It slowly starts deviating from this dotted line. This dotted line represents the actual Ohm's law. Okay, if you see in the graph, this dotted line represents actual Ohm's law, but at high temperature the graph tends to move away. Low temperature graph is very different, but the material behaves completely different based on the material also. So that's why it is not there. But high temperature, generally for all conductors, the behavior is same. Okay, the graph is no longer straight line, it bent curve wise. Now if you see this graph, Okay, if you see this graph, mostly up to this point, almost it's a straight line graph, almost. Okay, so you might say, okay, you have plotted up to this and you say, okay, this is this law, conductor is obeying Ohm's law. That's why you have to go a little further and inspect, see that whether it is actually true. Okay, and as you can see, at some value, after certain value, the current is decreasing, and if you see that for same current, we now have two different voltages. This is V1, this is V2. Okay, for same current I, we have two different voltages. That means obviously Ohm's law is no longer valid. So this case also Ohm's law is not valid. This is also a very specific case. Okay, so they have divided the graph into three different parts: linear region, non-linear region, negative resistance region. Okay, so Ohm's law is not valid in such cases. There are ways to implement Ohm's law, but that is not part of today's discussion. Maybe in PN junction chapter I will discuss. Now, how does a conductor reacts to change in temperature? Okay, what happens to its resistance? So resistance generally depends on length, area and resistivity. So resistivity is actually dependent on temperature. Resistivity increases with temperature for conductors, and this is called coefficient of resistivity. This term lambda is called coefficient of resistivity, okay, or coefficient of resistance as well. Both are same, because only resistivity changes, resistance increases proportionally. That's why you can replace the resistivity with resistance as well. Does not matter. You can write the same equation with RT equals to R naught 1 minus plus alpha into T minus T naught. So at temperature T, the resistance is RT. At some temperature T naught, the resistance was R naught. Now generally, if it is given as 0 degrees Celsius, we take that temperature as T naught, because that helps us. We do not have to add this T0. Okay, and these temperatures can be expressed in Celsius as well, Kelvin as well, but we generally express them in centigrades. Why? Because it is written in small t. That's why it is written in small t. Okay, Celsius or Kelvin does not matter. Difference is important. So difference in Celsius and Kelvin remains same. Okay, so whatever is difference in Celsius, the same difference is in Kelvin. So that's why it is independent of the scale of the temperature. Okay, here alpha is the temperature coefficient of resistance or resistivity. Alpha can be written as rho t minus rho naught. These few formulas that you have to remember: R naught, T minus T naught. In terms of resistance, RT minus R naught divided by R naught, T minus T naught. Basically, if you remember this formula, from this formula you can calculate this. Generally, they will give you alpha, R naught, RT, and they will ask you what is the final temperature. Okay, another way to determine if the temperature T naught is not 0 degrees Celsius, then it could be tricky to calculate, and in that case we use this formula to calculate alpha. Okay, this is a slightly advanced level formula, but if you remember this formula, some questions can be solved. Okay, in past 1 or 2 questions that can be solved using this formula, but these two formulas are more basic formulas. Any one of them can be used to solve such questions as well. So you don't need to remember this, but if you can remember it, it is better for you. Okay, again, T1 and T2 are two different temperatures, and resistances are at these temperatures are R T1 and R T2. Okay, so same thing like that, but none of them are actually 0 degrees Celsius. So in that case you use this formula. Okay, the resistance of a conductor is 5 ohm at 50 degrees Celsius and 6 ohm at 100 degrees Celsius. Its resistance at 0 degrees Celsius is. So basically, resistance of the conductor at 50 degrees is given, at 100 degrees is given. So let me explain and solve it. Then I will tell you, if exact similar question comes, how to solve it without doing any mathematics. This is because there is a less chance exact similar question will be asked that there is a shortcut method for that, but otherwise if it is a general question, then you have to do the mathematics. What is the mathematics? So at 50 degrees, say resistance is R50 equals to R naught 1 plus alpha 50 minus 0. Right, this is the formula. So from here we get R naught 1 plus alpha into 50. Right, now R50 is given 5 ohms, so 5 equals to R naught into 1 plus alpha into 50 or 50 alpha. Right, or you can write 5 upon R naught equals to 1 plus 50 alpha. Let it be equation number 1. What else? Now same way you can write the equation for 6 ohm at 100 degrees. So 6 ohm at 100 degrees means 6 by R naught equals to 1 plus 100 alpha. Right, this is equation number 2. Right, what we have done? We have solved it for one temperature and then we have replicated the same thing. So here this is the temperature difference. So temperature difference between 0 and 50 was 50. Temperature difference between 0 and 100 is 100. So we have just simplified it. Now if you multiply this top portion, now alpha value is not given. We will not solve for alpha. We just eliminate alpha. How to eliminate alpha? We multiply this equation by 2. Every quantity, we get 10 by R naught equals to 2 plus 100 alpha, and here we have 6 by R naught equals to 1 plus 100 alpha. Now you have to subtract minus minus minus. Okay, everything is minus. So 100 alpha cancels. We get 10 by R naught minus 6 by R naught equals to 2 minus 1. Okay, they already cancel, that is equals to 1, or 4 by R naught equals to 1. So LCM is same, LCM is R naught, so 10 minus 6, that is 4. So R naught equals to 4 ohm. Okay, so correct answer is 4 ohm. Now if exactly similar question is asked, similar question in the sense, if you see 0, 50, 100. So first is 0, then some temperature T, and then you have a temperature 2T. If this structure of question is being asked, it can be 0, 100, 200. Okay, it can be like that, or 0, 500, 1000, like that as well. Okay, so if the intermediate temperature is half of these two values, okay, that is half of this value 2T, okay, then only this logic applies, otherwise do not try to apply. This is the actual method of solving it. So if this similar question is being asked, it is given that T at 50 degree resistance is 5, at 100 degrees the resistance is 6. So in that method only it will be applicable. So what is the difference between 5 and 6? Difference between 5 and 6 is 1. So if you go from this direction, resistance is increasing by 1. Okay, so if you come from here to here, the resistance will be decreasing by 1. That means it will be 4. Okay, so 5 to 6 increase by 1. The temperature gap is same. So here the temperature gap is 50 degree. Here the temperature gap is also 50 degree. So in that case, if it is increasing by 1, so if you come back, it will be decreasing by 1. So that means it will be 4. So this is the shortcut method, only purely based on this fact, this question's fact. Okay, but this is the actual method of solving the question. Okay, both shortcut method as well as long form I have explained. Now combination of resistance, series resistance, parallel resistance, I will not explain too much about it. We have already done that in our class 10th. For series combination when the resistances are connected like this, okay, simply algebraically added. One important point is that if all the resistances are same, all resistances are same value, okay, and there are n such resistors, okay, so n such resistors connected in series. So in that case, in series, the equivalent resistance will be n into value of any one of them. Okay, so this is the equivalent resistance when n resistances of equal value connected in series. Okay, now in parallel combination, again 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Remember, this is reciprocal. So if you are using this method to calculate the equivalent resistance, ultimately you have to do a inverse of this to calculate the final value. This is a reciprocal, right? 1 by RQ. I have seen that students are calculating the right hand side properly, and at the end they are writing whatever they have calculated as R equivalent. They forget to take the inverse of the right hand side. Left hand side, the equation they have written right, but the right hand side they have done it properly for the first line. Second line, instead of writing 1 by REQ, they have directly written REQ. Okay, and the right hand side they do not forget to flip it. So that is a mistake. Do not do that. There is a shortcut method only if two resistors are there. If two resistors are there, for two resistors R1 and R2 connected in parallel, in that case the equivalent resistance can directly be written, and this is not the reciprocal one, R1 R2 by R1 plus R2. This is a shortcut method, and most of the cases you will encounter two resistors only. So in that case, this formula can directly be used to calculate the equivalent resistance. Okay, and if n such resistances are connected in parallel, okay, in that case the equivalent resistance will be R divided by n. If they are connected in series, it will be n into R, that is multiplication. If they are connected in parallel, it will be division. R equivalent will be R by n. So for series, n into R, for parallel, R by n. Okay, and R 1 by REQ is equal to, this is general formula, but mostly 99% cases we will not be using this. So we will be either using this formula where they will say that 10 resistors are connected in parallel. Okay, all of them have values, same values. So in that case you can use this. And in solving numerical questions, you will be encountering this one where two resistors will be connected in parallel. So you have to use R1 R2 by R1 plus R2. Right? Now electrical energy and power. Suppose a current is passing through a conductor. Okay, the electric voltage that you have applied is V. The current that is passing through the conductor is I. The current through the conductor is I. Then the energy generated in the resistor is given by H is equal to VIT. Sometimes we also call it Joule's law of heating. In lower sections, lower classes, we studied it as Joule's law of heating, which basically determines how much heat energy is developed. So how much heat energy means the energy that is spent by the resistor itself. Okay, so this is the heat energy that is spent by the resistor itself. Filtered 6K rank is very good. Why should you take a drop? 6K is a very good rank. You will get into top 5 colleges, top 3 colleges for any branch, top 5 colleges for CS branch. Maybe not RBC, maybe not PES, but you can still get into Dayanand Sagar. Okay, try for MSRIT. Okay, one of the computer science branches you will get. Why should you take drop? 6K is a decent, very good rank. Do not take a drop. If your rank was 60K and you are thinking that I want to take a drop, still okay. But 6K, why you are wasting your 1 year of your life? Don't waste. Okay. Filtered Harsh. So power is given by H upon T. Okay. VI equals to I square R, and V square by R. All of them are formula for power. All of them are formula for power. Based on the question, we will see which formula to use. Just remember, power is equal to Vodafone Idea. That is the simplest formula to remember. Power is equal to VI. Okay, Vodafone Idea. Now, this is not relevant. Let's see one question. If voltage across a bulb rated 220 volt 100 watt drops by 2.5% of its rated value, the percentage of the rated value by which the power would decrease is. So power rating is given, okay, the voltage drop is given, and based on that they are asking how much will be the percentage drop of the power. Okay, now remember that if voltage is decreasing, current will also change. So we cannot use power is equal to V into I formula. What formula we will be using? We will be using, let me change the color. Power equals to V square upon R. Because R is constant. No matter what is happening, V changes, I changes, resistance of the conductor is constant. It does not depend on voltage, it does not depend on current. So resistance is constant. So power can be written as V square upon R. Now this is a change, percentage change. So percentage change problems we solve like this. Percentage change based problems we solve like this. First we differentiate both sides. So dP is equal to d of V square upon R. R is a constant, so it does not get differentiated. So dV square by R. Now V square means we can write 2V dV upon R. Right? We can write it like this. Now next step is we divide both sides by the power. Okay, this represents the percentage change. This represents the percentage change in the power. So dP by P equals to 2V dV. Now see this side there is an extra power that we cannot cancel. So what to do? Instead of writing power, we will write the original formula of power on the right hand side. So on our right hand side we will write V square upon R, and then we will try to simplify it. Obviously both R's were in division, division of division, so they will cancel each other. This will go up and multiply, so R cancels. Now we are left with 2V dV upon V square. 2V dV upon V square. Now again one of the V will cancel and we are left with 2 into dV by V. Now once you are master with this, you can simply say that okay, P is equal to V square by R, then that means dP by P will be 2 dV by V. So that to write from this equation to this equation takes some time, some practice, okay, but definitely you will achieve that if you continuously practice that. Okay, so dP by P is equal to 2 dV by V. Now this is the change in percentage, this is the change in percentage, this is the change in percentage of voltage, this is the change in percentage of the power. Okay, so dP by P equals to 2 into what is the change in voltage? Change in voltage is 2.5%. So 2.5%. So instead of dV by V, we'll simply write the change in voltage. So that means it will be 5%. So dP by P or change in power will be 5%. So change in voltage is 2.5, change in power will be 5%. Okay. Now two daily practice questions. One of them I have discussed during my lecture, so check that out. A wire of certain material is stretched slowly by 10%. Its new resistance and specific resistance becomes respectively 1.2 times same, 1.1 times, 1.1 times, both remains the same, 1.2 times, 1.1 times. You have to figure it out and solve it and mention the answer in the comment section once the live is over. Okay, so solve the question Find the answer. If A is correct, mention A, B is correct, mention B, C is correct, mention B, C, or D is correct, mention D as well. Next question. A copper wire of length 1 meter and uniform cross-sectional area 5 into 10 to the power of minus 7 meter square carries a current of 1 ampere. Assuming there are 8 into 10 to the power of 28 free electrons per meter cube in the copper, how long will an electron take to drift from one end of the wire to the other? So first step is to I is equal to NEA VD. Okay, I is given, N is given, E is known. Okay, area, cross-sectional area is also given. So from there you calculate VD. What is VD? Okay, so VD is calculated, but the question is not asking you about VD. They are asking how much time it will take. So if you see that the question has the length of the wire to be 1 meter. So drift velocity is known, length is known, then from there time will be equals to length divided by drift velocity. Time will be length divided by drift velocity. So if you do that, you will find the answer. So follow the step, find the answer, mention that in the comment section below as I mentioned. Okay, and now let me discuss more about Pariksha Veera. Sanath Mallikarjuna, yeah, we will check with them, okay, what is happening, why they are not taking classes. But in the meantime, come here, join our classes. Maybe you have some probably some language issues, I know, because we teach in English, you may prefer Kannada as well, but yes, join here. We are also teaching, they are also teaching, they are we both are our parents are same. Okay, we will check what is happening there as well, if why the classes are not happening. But yes, the information will be definitely, I will pass it off. But in the meantime, learn from us at least. You will not miss out, right? We are doing classes regularly, except chemistry. We are doing regular classes. Chemistry teacher is also on the way, so we will start chemistry classes as well. So Pariksha Veera batch is very, very important for those who are preparing for KCET 2027 exam, right? So here you will be getting 110 plus hours per subject. Okay, 110 plus hours per subject. It is not in a one single day. We are taking classes every day. So 6 days a week there will be classes. Second and fourth Saturdays will be off. Every Sundays will be off for your revision as well as some internal tests. So that means 20 plus tests per subject we are giving. Okay, part and full length. Part test means weekly tests, monthly test, like that, and full length test means full syllabus test when our syllabus is complete. Okay, and basically this batch is valid till 31st of May. That means till your KCET exams are over. Even beyond that, you will get teacher notes, assignments. Okay, unlimited DPP generator is also there. You can generate your own practice questions and practice as much as you want. Okay, and we are going to deliver in the Wave platform of Vedantu, which is the one of the most acknowledged online platform for online teaching. So you will not miss out your classroom, that is guaranteed. And the price of the batch is 3499 only. Batch already started. If you want to join, if you want to learn in a more structured manner, definitely join today. The link of the Pariksha Veera batch is also given in the description, right? So this is the end of today's lecture. If you have any other doubts, okay, Shantama Mallikarjuna, I will definitely inform from my side, as I mentioned. Okay, and in between that time, please study from us if you want, right? If you do not have any question, I will end the live session over here. Okay, time is up anyway. Thank you everyone. Thank you.